classes, we have seen the thermal, thermal power station, schematic arrangement of thermal power station. What are the components in the thermal power station? What are the advantages and disadvantages, of building that thermal power station? So like that, we have seen, and what are the components, major components in the thermal power station? So what is the role of the thermal power? What is the role of the components? So what are the different types of components that is being used? So what is the advantages and disadvantages of that types of components? So which are the components is being used in the thermal power station for the optimal operation? Okay, like that we have seen in the thermal power station. So next is hydroelectric power station. Okay, so a generating station which utilizes the potential energy of water at high level for the generation of electrical energy is known as hydroelectric power station. Okay, so it utilizes the potential energy of water at high level. Okay, so water, as I already said, water is stored in one second. So water is stored in the very high level. High level means in the dam. Okay, so dam somewhat around here. So your generation might be happening here. Okay, so why this generation is happening here instead of here itself? Na? So the water has to flow. Some that potential energy of the water is being get utilized. Okay, so water, if water will flow from high level of altitude, na, so you'll get more energy. Okay, so that's why we are going for this hydroelectric power station in the somewhat lower than the dam level. Okay, it is not exactly in the dam level, so lower level of the dam level. Okay, so here if you see, hydroelectric power stations are generally located at hilly areas that dams can build conveniently and large waters can be obtained. Okay, so why this hilly area? Okay, so why this hilly area means, say for example, here, yeah. What is the pin? The pin is not showing. Something has happened. So here, why we are going for hilly areas means in the hilly areas, you need no need to construct a dam itself. Okay, so why? Because between the two hills you can easily store the water. Okay, so between the two hills you will get some valley. Okay, some nature itself. Okay, in some areas nature itself, you no need to construct any. Okay, you have to dig the um, the sand and all. So just like that, the construction, that is the nature itself will be acting like a dam, or otherwise sometimes what they will do is they will dig more. Okay, they will construct the dam. They will construct the dam in some okay top areas. Okay, that is some hilly areas they may construct. Okay, so why? Because dam can easily built conveniently and large water reservoirs can be obtained. Okay, so large water also you can store. Okay, in hydroelectric power station, water head is created by constructing a dam across a river or lake. Okay, either in a lake or in a dam. Okay, so lake, if big lake is there, so in that lake also you can okay, construct a dam, like a dam like structure, and also you can yeah, generate the power from that. Okay, so but the lake should be very big, and the water okay, so if it is rains only in the lake and all, you can generate the power. Okay, so then if from the water, from the dam, water is led to the water turbine. So the water turbine captures the energy in the falling water and changes the hydraulic energy. Okay. So as I said, that water energy, water is only okay hitting the turbine to move. Okay. So here the changes the hydraulic energy. That is product of head of flow water is converted into mechanical energy at the turbine shaft. Okay, so the turbine drives the alternator which converts mechanical energy into electrical energy. Okay, so hydroelectric power station are becoming very popular because reserves of fuel, okay, it's like a coal and oil are depleting day by day. Okay, so we can't rely on coal. As I said, only 30 years. Okay, after 30 years, no coal resources will be available all over the world. Maybe it may be available, but very few. It may be very few. And oil also, the crude oil is also for only some 40, 50 years. After that, we don't. Okay, so we have to rely on some other technology, So hydro also becoming very popular, but so if rains, if it is rains for a day, or if it is if we expect a good rain in a month or in a year, so you can simply go for generating power from electric power. Okay, hydroelectric station. Okay, so these have added importance for flood control, storage of water of irrigation, and water for drinking purpose also. Okay, so for the construction of dam, not only for generating the power. Okay, so like if there is okay more flood in the river. Okay, so you can store that water. You can store that water, and also that stored water can be utilized for your irrigation. Okay, then drinking purpose also. Okay, so Krishna water we are getting in Hyderabad. The Krishna water we are getting. So from the dam, so it is traveling around 200 kilometers. Okay, so from the dam only we are okay utilizing for drinking water. Okay, and also for the irrigation. Okay, so irrigation also. So once, say for example, if they decided to generate the power from hydropower station, so they will utilize for both. Okay, one is for generating power and as well as for irrigation also, because once the water gets out from the dam, So you can't take it back. So even though you can take it back, that is, you can pump that water, same water from the lower level to upper level of the dam. So as I said, like uh, you need a more amount of power to pump that water from lower stage to upper stage. Okay, so that will be the stage by stage. Say for example, this is the dam one, stage one. Okay, this is the power generation happening in the stage one. So after that, again after some kilometers, okay, that water might be flowing. Okay, so that will be the dam stage two. Okay, stage two. Maybe the dam one may be of some okay, so 5 kilometers or like that. Okay, so that dam, okay, in that dam the water will be stored. Okay, simply like that, you can't let that hold water. Okay, so we are utilizing some TMCs of water for irrigation and for drinking water, and as well as generating the power. Okay, so that water will be stored in the stage two. Okay, so stage two, that in that stage two, what we are doing is again we are generating the power from stage two, and again third stage. Like that, maximum, okay, depends on the mountains, depends on the hilly areas. They may construct the dam, stage one, stage two, stage three, like that. Why? Because if it is only one dam and only one generation means, so once, say for example, you are generating the power of 500 megawatt from a dam. Okay, so simply like that 500 megawatt, after that will be wasted, not wasted. It may be going for irrigation and for drinking water, like that. Okay, but after that also it may be okay, stored in the stage two. Stage two, again we are generating the power. Again we are generating around 500 megawatt or 200 megawatt. So again stage three, again 100 megawatt. Again some it may be flowing to some other okay regions. There we are constructing mini hydropower. Mini hydro nowadays, a mini hydropower plant also they are constructing. So mini hydropower plant, what we are doing is we are generating around 10 megawatt, okay, 20 megawatt, 30 megawatt, 50 megawatt, small generating units. Okay, so like that 10 megawatt we are generating. So 10 megawatt, again that water is letting to like irrigation purpose via canals, like that. Okay, so what are the main advantages of this hydropower station? Okay, so it requires no fuel. Okay, so coal, you need fuel. Without coal, you can't generate the power from thermal generating units. Okay, so no fuel. Okay, so it requires no fuel, as water is only used for generation of electrical energy. So water is free. Okay, so we are not getting water from any. Okay, so water is free resources. Okay, so and also it is quite neat and clean. No smoke or ash is produced. Okay, as I said in thermal power station. So ash, the fumes are not coming out. Okay, so that fumes will be very harmful for our living creatures. Okay, so next one, it requires very small running charges. Very small running charges, because water is the source of energy which is available at a free of cost. So the running charges is zero. Okay, so running charges is very small. Okay, only that tubes. Okay, tubes we have to construct for um, uh, generating the power, and it is comparatively simple in construction and requires less maintenance. Simple in construction. So if you take like a thermal power plant, for constructing thermal power plant, so many things are there: boiler, superheater, okay, then economizer. Many you have to construct a water recycling unit, feed water pump, like that. Many components are there in thermal power station. But if you see like here, the construction is very, very simple, and also it requires less maintenance. Okay. Next, it does not require long starting time like steam power station. As I said, in a steam power station, for starting the steam power station is not at all an easy task. Because if you want to start a steam power station in like 9 o'clock in the morning, so you have to start the process by 8 o'clock or 7:30 at least. At least it will take some 1.5 hours for for the plant in operation. Okay, if you want to integrate, if you want to just connect that plant that is thermal power station to the bus or a grid. So definitely it needs 1.5 hours of time to connect to that particular grid. So why? Because you want to heat the water. Okay, your furnace has to get heated up. You have to burn the coal. Okay, burn the coal for sometimes some half an hour. So then only you get more amount of heat. You can simply, if you heat the coal, your water will not heated up. Your that potential energy created in the steam will be very, very less. Okay, with that steam, simply you can like a steam bath we are taking. No, steam bath. Steam inhalation we are taking. Okay, so initially, if you are going to inhale that steam, okay, that will be very, very powerful. So after sometimes that steam also will be losing some energy. Okay, so that if you inhale also, it will not able to inhale. So like that in steam power station also, superheated steam is needed. So definitely it will take 1.5 hours of time for that plant to be in the operation. Okay, so it requires long starting time for steam power station. Whereas in hydropower station, you can simply generate the power. It will also take some time, like 5 minutes of time. Okay, so not more than that. So in fact, such plants can be put into service instantly. Okay, instantly you can put it to service. In the load dispatch centers, they are telling like suddenly they need to on due to the increase in demand, they need to on another 200 megawatt of power. Simply like that you can on, but not in steam power station. Steam power station you have to wait for. Okay, if you want to add another steam power station, so definitely you have to wait for 1 hour. So next, it is robust and has longer life. Okay, robust in design and longer life also. Once it is being installed, only the thing is that maintenance is needed in turbines. Okay, because water is that turbine is directly getting contact with the water. No? So yeah, you need to go for maintenance every in a month or 2 times. Like that, you need to go for the maintenance. Okay, or otherwise nothing you need to replace like that. Okay, boilers in steam power station, boilers you need a frequent maintenance, and also turbine also you need a frequent maintenance. Whereas in hydropower station, only turbine. Okay. Next, such plants may serve many purposes. Many purposes. In addition to the generation of electrical energy, it also helps in irrigation and controlling the floods also. So main thing is irrigation. Controlling floods, nowadays it is not raining that much. So this word, I think this time it is not used for controlling the floods. Sometimes maybe 5 years once like that, somewhat. Okay, so 1 year back, some 8 months back, it was heavily rained in Hyderabad. Okay, so by that time, maybe for controlling the floods, it happens once in a while, not every time. Okay. So next, although such plants requires attention of highly skilled persons at the time of construction, head for the operation. A few experienced person may do the job. Okay, I said in thermal power station, you need 200 employees for running that whole thermal power plant. But whereas in hydropower station, only few employees is enough. Okay, some 10 to 15 employees may enough to run the whole station. Not like that thermal power station. Next, what is the main disadvantages? It involves high capital cost due to the construction of dam. Okay, construction of dam is not at all an easy task because you need to construct 15 kilometers. Okay, that path also you need to construct, and that the construction of dam. Okay, so heavy concrete structures is needed. So it will take some time, and also a high capital cost also needed. Next, there is uncertainty about the availability of huge amount of water due to dependence on weather condition. Okay, so only it is the due to the weather condition. If it is rains, then the water will be stored is more in the dam. So if it is not rains, means again we have to expect the rain. Okay, so in that kind, or otherwise the storage water you can use, but in summer season and all you have to use okay, wisely. Why? Because once it is being used only for power generation, then water scarcity will come. So drinking water scarcity will come throughout the city or throughout the state. So we have to very careful while running this hydropower station, especially in the summer seasons. In these seasons, like March to June. So yeah, we have to very careful. Next, skilled and experienced hands are required to build the plant. Okay, so you can't simply build the dam like so. Okay, so what? So the house and all. Okay, civil engineers and all. Without the civil engineers also you can construct the house. Okay, with your masons you can easily construct the house, but not for the dam. Okay, so dam you need some experienced hands. Okay, so design and all based on the location you have to change the design. Okay, so generally the dam construction might be of common, but based on the location, based on the hilly regions, based on the location, you need to construct the dam. So that needs some experienced hands, and so maximum potential energy you have to extract from that water. So like that, so all the dam construction will not be the same. Okay, so some okay, design might be changing in different dams. Okay, so you need some experienced hands. So next thing, it requires a high cost of transmission lines as the power is located in hilly areas, which is quite away from the consumers. Okay, if you take the hilly areas, it is somewhat very okay, far from the consumers or low dispatch centers. So nearly some 500 kilometers long, 400, 500 kilometers long. So 400, 500 kilometers, you have to transmit that power from hilly areas to consumers. And also, while constructing the towers in the hilly areas, because mostly your hilly areas will be in the forest range. Okay, so while then there may be some wild animals sanctuary and all. So constructing the transmission lines in the inside the wild wildlife sanctuaries, you need to go for very careful construction, because if so in plains okay, in plains you can easily construct the transmission towers, but in hilly areas it will be like this. Okay, so it will be like this. Okay, you want to construct the transmission tower over here now, So the transmission line will be passing like this. Okay, so if the transmission lines is passing like this now, so the clearance between the ground to tower will be ground to transmission lines will be very less. Okay, so sometimes your wild animals like elephants, okay, like that some animals might be crossing that areas. So it will be okay. So sometimes your elephants also will be touching that towers, because while constructing the tower itself, you need to go for very high altitude. Okay, so you need to go for very you need to construct the line to ground clearance might be very high, so that okay, it will be not harmful to the animals also. Okay, so that also very important while constructing this kind of transmission towers, especially in the hilly areas, not in plains. Plains, no problem. Next, disadvantages. It involves disadvantages. We already seen that. So this is the main disadvantages in this thing. But even though advantages are more. So next, schematic arrangements of this hydroelectric power station. Okay. So although hydroelectric power station simply involves conversion of electrical energy to electrical, it embraces many arrangements for proper working and efficiency. Okay, for proper working and efficiency, you need to construct that power plant very okay in the very careful manner. Okay, dam is constructed across the river or lake, and water from the catchment area collects at the back of the reservoir. Okay, so that's what I said. The catchment area. Catchment area is nothing but between the two hills. Between the two hills, okay, automatically you get some okay valley type. Okay, say for example, one hill like this. Okay, another hill like this. So in between that two hills, there will be some catchment area. Okay, so in that catchment area, easily you can store the water. Okay, you no need to construct any any dams in between the two hills. Okay, so nature itself, okay, will give the hand. That is called catchment area. Catchment area. So easily you can collect you can store the water in the catchment area. So from the catchment area, whenever it is needed, you can take that water to the dam. Okay, so if the dam level of the dam is dropping means, so you can simply open the water from the catchment area. Okay, like that. So next is pressure tunnel. Yeah, pressure tunnel. Yeah, a pressure tunnel is taken off from the reservoir and water is brought to the valve. Okay, pressure tunnel you need to construct from the reservoir. Okay, and water brought to the valve house at the start of the penstock. So pressure tunnel. Okay, so you have to create a pressure tunnel like this. Okay, so your dam might be here. So why we are going for the pressure tunnel? Because simply like that also you can construct a penstock like this. Okay, so instead of getting more okay your potential energy, so what we are doing is we are running one tunnel. We are running one tunnel like this. Again, we are going for the penstock like this. Okay, this is called penstock. This pipe is called penstock. Okay, pipes or tubes, whatever you can take. Okay, pipes. This kind of pipes. So pressure channel also what we are doing, we are running the pressure channel for some distance. Say for example 1 kilometer, half kilometer. We are running that pressure channel for some distance. So the penstock. Penstock means one pipe. Okay, like a 45-degree angle, 60-degree angle. Okay, like that we are constructing. So what is the need of this pressure channel means to get the more pressure from the water, to extract the more pressure from the bottom. As I already said, your water while hitting the turbine. So your what will be the speed of the water will be like 150 kilometer per hour, 120 kilometer per hour to 150 kilometer per hour. Okay, if the pressure will be like that only, then the turbine will turn. If water simply hitting the turbine, your turbine itself will not get turned, or otherwise it will turn. Okay, so only with a few RPM. Okay, in the lab you're doing, no, like in the next cycle you'll be doing the alternators. Okay, now we are running only motors, three-phase motors. In next cycle you'll be running the alternators. So by the time you have to give some because in the lab alternator is simply coupled with the motors. Okay, so why? Because we can't generate okay, we can't generate power. Okay, so what we are doing is a motor is coupled with the alternator. So simply like that, this motor is running, meanwhile the alternator also running. uh, uh, See, imagine you're doing same thing in the uh, um, power plant also. That is hydroelectric power plant also, turbine also. That turbine has to rotate in some more RPM, but not like in lab. So not like in lab, it can't rotate in 1500 RPM. If you see like the hydroelectric power turbine, so it will be rotating in only 200 RPM. Okay, 200 RPM only. But the power generated from the that turbine will be more. And that is of 100 megawatt, 500 megawatt, 200 megawatt. Like that. It depends on the type of the plant. Okay, so pressure channel, you know, now pressure channel is used for is taken from the reservoir, brought to the valve house to the start of the pen stop. Okay, so pressure channel is connected to the pen stop. Okay, a valve house contains main sluice valve and automatic isolating valves. Okay, so one valve house will be there. Okay, you can see this valve house will be not this will be the power house. Okay, this will be the power house, this will be the valve house. So valve house somewhere around in the top okay, some workers may be working, one or two workers may be working in the valve house. The valve house, what they will do is they will simply open that valve, or close that sluice valve. Okay, or sometimes automatic isolating valves will be there. Okay, sometimes if rain is more, what they will do is they will simply generate okay, they will simply open that okay, spill base. You call that as spill base. Okay, so one photograph if I show now, you will get some idea. I'll show one photograph. So it's not opening. Some format got changed. Yeah. So this is the exactly the spillway. So in which what is the need of the spillway sense? So in the dam, the spillway is always closed. Okay, if you see like yeah, gate will be there. Once a big gate will be there. Always it will be closed. Okay, so if dam is get overflowed, okay, dam is get filled. Okay, due to heavy rain, his dam is getting okay filled. Even though we are generating, but the dam is filling like anything. Okay, but in that case, what they will do is they will simply open this spillways. Okay, simply open this spillways. Okay, so the excess water that is harmful to the dam because there is some maximum capacity of the dam. Even though, say for example, if you want to store the water up to 120, you can store the water up to 120 feet in the dam. But for the safety of the dam, they will only store up to 100 feet. Okay, they will not go beyond that 100 feet. Okay, so if they go beyond the 100 feet, okay, definitely your dam will be in the very big problem. Okay, so simply that construction and all will get okay will get damaged. Okay, I will show some videos in the class. Okay, the construction and all will be get damaged. It will be get busted. Okay, recently in China, what they did is due to the okay over flowing of the water, so they don't know what to do. So what they did is they simply blast the dam. Okay, so even what it will happen is it will cause very huge okay, loss. Okay, so what they did is they simply blast that whole spillways so that everything gets open. So simply it is that water will be flowing and it will be going to sea or a river, and after that river it will go to sea. Okay, so like that also it happened. But here in our okay in our southern India, so water is not due to the okay rainfall. If only rainfall only this dam is getting filled up. Otherwise, so what they will do is they will definitely open this spillway. Okay, they will not simply let the okay thing just like that. Okay, this simply open this spillways. Okay, so there will be some valve house. So in the valve house, so water is being that the valve will be there. Okay, so based on that they will open and close. So what is the pressure you want in this power in this powerhouse like that. If it is 500 megawatts, they will open fully. If it is 100 megawatts, they will close somewhat a little bit. If it is 200 megawatts, like that, they will open and close the valve. And nowadays, automatic automatic valves also is being installed based on the power generation here. It will be opening automatic like that also that. Then this is the pen stop. This is the pen stop. So it will again go to the second stage or river or goes to the second stage of the dam. Second stage of the dam. Okay. So up to this, any doubts? I think